So today I'm going to be talking about React and Redux and the one-way data flow as an architecture. And who am I? I'm Tyler Wanek, and I work at Axosoft on the GitKraken product. And I'd like to start by teaching you guys a little bit about Git and what it is that we're doing with GitKraken. So GitKraken is version control software. And if you're unfamiliar with that, it's an easy way to collaborate with other people. That when you're working on a project, you can think of it a lot like Google Docs, where everyone can work on the same document, and they can all submit different changes to that document, and you can see those changes as a team. It was developed by Linus Torvalds in 2005 for the Linux kernel development. And it is primarily a command line utility. And this is a fun little comic about Git. It's from one of my favorites, XKCD. And in it, they're talking about Git, which is a directed acyclic graph of immutable nodes. And the kind of important point of this comic is when asked, how do we use this, the person who's introducing Git says, I have no idea. I just memorize these commands, and if I screw up, I just delete the whole thing and re-download it. And I copy my changes. And we think at GitKraken that that's a problem. So what we're doing with GitKraken is we are trying to simplify the Git experience. We want to make it easier for anyone to use GitKraken, or for anyone to use Git, and we feel like there's a huge usability problem with Git, even though it's a very wonderful tool. We also look really great doing it, and that's awesome. So it's a great user experience. And I just want to reiterate that our main goal of GitKraken is to make Git very intuitive and easy to use. We want to just completely lower the bar for anyone coming into the product. So GitKraken supercharges Git. And today we're going to be, so now that I've kind of talked about GitKraken and Git, we're going to, here is some information you guys can use to follow along. For today's talk, I won't walk you through these steps specifically, but we're going to be using GitKraken in this talk. We're going to be using Node, and so you can install that on Windows at nodejs.org, and you can install that from Linux and OS X on the CreationX NVM repository. And we'll be working with a repository, didn't scale too well there, so you probably won't be able to see that. We'll have to post a link to it in our video. But it's github.com/implausible/Redux soda demo. Again, we'll just have a link in the video. And so before I get into this whole React and Redux talk, there are some prerequisites that we're going to need to get familiar with. And so we're going to jump over to Atom, which is my favorite text editor. And I have some examples in syntax that I'm going to be using, and just basic concepts that we're going to be using for the rest of this talk. So I think first what we'll do is we'll start with our functions. And let me blow this up a little bit and remove the tree. So first, let's take a look at just your classic JavaScript function. And you'll probably, if you've seen JavaScript before, you've seen this version of the JavaScript function. So I have some function, a JavaScript function, and it returns 1 + 1. I'm going to blow that up one more time. And so this is kind of the classic JavaScript function. And when we call it, it's going to return 2. And we'll run this code in a little bit, but I'd like to walk through it first. And then we also have the classic anonymous function. This is another construct in JavaScript. And that's functions in JavaScript are first-class objects. And that just means that you can pass them around just like any other variable. So it's just like a number, or it's just like an array or an object. It's something that you can assign to another another name. So in this case, we have a variable called an anonymous function. and we're assigning the function that returns I don't have a name to that variable. And so when we run this code in a bit, an anonymous function will return this, and it will be output here. Okay, so now we're going to get into the syntax I will be using explicitly. There's just some background to help you guys link the two concepts. So today in JavaScript, we've made a lot of effort to improve the usability and feel and looks of JavaScript. So today we have these functions which we call arrow functions, and our arrow functions look like this. It's just like an anonymous function. You have to assign it to a variable. So I have some constant and arrow function. That's the name of my constant variable. And I'm going to assign these parentheses with this arrow-looking guy and a function body to an arrow function. And this is just the same as up here in the anonymous function. The only difference is that our parameter list is actually here, and we have this arrow that points to the body of our function. Okay? And so, as you can expect, if I call an arrow function, and we call an arrow function here, we should get some random number from 1 to 100. Okay? And so, lastly, I'm going to talk about one last piece. Ooh, it's a little short there. Why don't I see if I can scoot this up a bit? Ah, great. All right, so this is an arrow with shorthand return. I'll be using these almost exclusively throughout the rest of the talk. And what this means is that here's your typical arrow function declaration, and this is the return value. So we've omitted our brackets, and we've just passed an expression back, and that is the return value of the function. So when I call arrow with shorthand return, I should receive, if we omit the brackets, this must be an expression. And so we'll go ahead and run this code. And for those following along, you can do this by typing npm run concept. And the concept that we're working with is functions. And so I wish I could blow this up for you. We'll have to have some screenshots in the video. So in this, we have our classic function, which had a return value of 2. Our classic anonymous function, which has a return value of, I don't even have a name. And we can, where'd my mouse go? We can see those are our expectations. And here we received some random number, 31, for that arrow function we declared. And finally, we received that string in the bodiless arrow function. So that's the first bit of syntax. I'm going to teach you guys about ES6 today. So why don't we go ahead and move on to the next one. You guys are probably all familiar with this. These are objects in JavaScript. So today, let's just look over just the basics of objects. We're just going to review this. So we have first some variable called some important thing, and I'm not arbitrary, I swear. And we have an object. I just called it a JavaScript object, and it has some keys in it. And this is a property called key, and it has the value, the string value. And this is a property number, and it has the value number 1. And we have another object, that's the property, with another object that contains the property with key, which has the value, oh my. And finally, we can assign variables into this object with colon. So some key equals some important thing. So some key will take the value, I'm not arbitrary, I swear. And what we'll do is we'll log this out when we run this, just to show how this looks as a JavaScript object. We'll just have some string representation of it. And then there's kind of the basic object read is just we're going to dump it out to the object. And then there's one bit that I'm going to be using exclusively when I work with objects. is called shorthand assignment. So this is another ES6 concept. It's very handy. So I have this variable, this constant variable, shorthand assignment, and I want to create an object. And you'll notice that I just said it has some important thing, and that's it. There's no colon, there's no value. I just said it has some important thing. And what that ends up becoming is it will break down to the same, some important thing. So it's just shorthand, and it just means that key, that property, has the value of the variable, some important thing, which was, I'm not arbitrary, I swear. So we'll go ahead and we'll run this, and we should see as our output so here we should see our objects, which ended up being an object with a key of value, a number with the number 1 as a value, another object which has another object as value, which has with key, oh my, and then going back to the top level object, we have some key which is equal to I'm not arbitrary, I swear. And with the shorthand assignment, we got exactly what we expected, which is some important thing is I'm not arbitrary, I swear. All right, so let's move on to the next concept. The next concept is, I might have to check my folder tree. Destructuring, okay. So we're going to move on to destructuring. We're going to see this a little bit in this talk as well. So I'm just introducing some ES6 concepts. It's a really wonderful tool. And you'll find if you work with React or any JavaScript library today, you'll want to incorporate some of these things into your workflow. So we're going to talk about destructuring objects. And destructuring objects is just a way to, well, it's a little bit difficult to explain, but we have an object here with the keys A, B, and C. So these are the properties of an object, and they have the values 1, 2, and 3. Now, I want to create a variable called A that has the same value of A from an object. And so what I can do is I can use a destructuring syntax. And so when I declare my const A, B, and C, I surround it in object notation. What this means is that I want A to take the value of A from an object. I want B to take the value of B from an object, and C from an object. So my expectations are that A should equal 1, B should equal 2, and C should equal 3. Following that, there is one other concept I'm going to be using today, which is called spread notation. And specifically, we'll be using spread notation with objects. This is not explicitly an ES6 feature, but it's a very wonderful feature. Hopefully, it will come down the pipeline soon. Right now, we'll be compiling to get this feature. That's a whole other subject, but just know that we've got the compiler hooked up in this. So I have some constant object. I can't help but think we could blow this up a little more. I have some constant called object1, obj1, and it has the keys A and B. A is hello, B is world. And I also have a constant object2, and this just contains goodbye. So what I'm going to do is I'm going to use the spread syntax, and the spread syntax is a way for me to say I have this collection of things. So in this case, I have this property A, or I have this property A and B. I have this collection of things, and I want you to just take all of these things and unravel them so that I can use them in another way. It's one of those things that you'll get it when I show it to you, but it may not come out as clean with English. And so the syntax looks like this. It's ... And so I have this object I'm creating called spread starting with object1. And so I open my object brackets, and I'm going to spread object1. And then I'm going to spread object2. What this is going to do is it's going to take all of the keys, all the properties of object1, it's going to put them in here. Now it's going to take all the properties of object2, and it's going to put them in here. And so if you think about this, if you were to say flip the order of these, so if I took all the properties of object 2 and I put them in the spread starting with object 2 object, and then I took all the properties of object 1 and I spread those out, I should get the inverse. So what I should see for the first case is I should see goodbye world. A little sad. But when I flip them, I should see hello world, because we're spreading object 2, which has the key A with the value goodbye, and then immediately after that we're spreading object 1 with A and B, and since there's an A incoming, I'm going to overwrite the A in the other one. I hope that makes sense. We'll link to some helpful descriptions of destructuring online. Okay, so let's go ahead, clear this out, and let's give that a little run. So we're gonna do npm run concept destructuring. Oop, destructuring doesn't exist. Oh no, what have I done? Destructuring. Did I spell it wrong? Destructing. Haha. I found the problem. Okay. So here what we got is, as I was talking about earlier, we got those values directly out of that first object. So we got A, B, and C. They had the values 1, 2, and 3. And then we have our spread operator, which when we put object 1 first, followed by 2, we received A is goodbye and B is world. And when we merged them in the opposite direction, we got hello world. And again, that's because we're overriding the key by the order that we're spreading and merging these objects. Okay. So now there's one last concept that I want to touch. This is not so much about syntax that I'm going to be using. This is about the concept of immutability. And this is a staple in React and Redux. And that's why it's very important that we talk about it today. So I should have this file immutability. And in immutability, first I'd like to talk about just line 3, which is const test equals 1. And what that implies. It implies that test is a constant value, cannot be changed. Its value is 1. If I try to change that, I should receive an error. It should break. And so what I'm going to do is I'm going to just run this script I'm going to run this script, which is, I'm going to run this concept, which is the immutability concept. And we received a syntax error because test is read-only. We can't assign to it anymore. It's already been created. It has a constant value. And that is what we're looking for with const in this case. So I'm going to comment that again. Now I'm going to tell you the downside of that. This does not apply to, this const does not apply recursively into our objects. So even though I have object 1 or I have object 2 and it has some properties in it, I can change those properties without actually changing test or changing object 1. These are mutable things inside of a constant value. And what this is all about is referential equality. JavaScript is a little bit weaker with these things. And what we want to do when we're talking about referential equality is look at object 1 and object 2. So for referential equality, we have two objects. They look exactly the same. They have the same keys. The keys have the exact same value. One of them is being assigned to object 1. One of them is being assigned to object 2. However, here's the deal about referential equality is that object 1 is the same as object 1. Object 2 is the same as object 2. Object 1 is not the same as object 2. So these two may have the same structure and a similar shape, but they're not the same thing because this object is unique from this object referentially. There's some identifier in the system that says this is this object, and object 1 is a different object. And so where we're going with this is when I say immutability in our talk, what I mean is that we will not mutate objects. And mutating objects, how that works is I have that constant object 1, and I can list the object 1 before I make a mutation. And a mutation just means that I had that property key, and I can set it to new value on object 1. So I have object 1 which has A and B, and I can set the property key on it, so I'm adding a new property, and I can set it to new value. And after I do this operation, object 1 it's still object 1, hasn't changed at all. Even though I've changed the object, I haven't actually changed the reference to the object, the identifier of that object. And so what we're doing here is we're mutating it. We are changing the structure internally of it without announcing to the outside world that it's different. So when I say immutability, we're going to be simulating immutability by, say we're going to be simulating it with this spread operator, these merge operations, okay? And so an update without mutating actually looks like we create an object 3. So we open up a brand new object 3. It's a brand new object, and we're going to spread the object 2 properties into it. So we're going to take the A and the B that we had above in object 2. We're going to plop them right here. Now I'm going to write a new key, 3, or I'm going to write A as the value 3. So what I've done is I've created a brand new object. I've given it all of the same content that the old object has, just completely copied it over, and I've only changed A to be 3. And the result that we get from that is a pseudo type of immutability. We have our object 2, we have our object 3. You'll see that they have different structures now because A will be 3, or they'll have different values because A will be 3 in object 2 or object 3, and A will be 1 in object 2. And the important part here is that object 2 is still object 2, but object 2 is not object 3. And this concept's going to be really important when we get into Redux. So I'm going to throw this out there again when we get there. And so that kind of concludes just getting to getting all of our stuff together here for the React and Redux talk. So that's all the prerequisite knowledge that I need you guys to have before we get into this.